Sorry?
Um, I said I'm testing out a new recording software today. Um,
Okay.
yeah, just wanna record everything so that because the other ones I saw when I listen to them, the
Mm,
audio doesn't come out well and the screen as well. But
okay.
um, let me share my screen. Mm, oh, mm, okay. You can see my screen, right?
Yes, I can.
Okay. So I want us to continue from
Okay.
you said it's functions and graphs and then what?
And so it's calculus.
Calculus.
Yes.
Okay. Which part exactly?
Um, what question? Um, which bit for you? Okay. Um, it's that one on question 8 on calculus. Because I saw that the graphs on calculus are kind of like similar to functions and graph.
Hmm. Which one? Which question 8? Are you talking about cubic graphs?
Mm, yes.
Okay, the ones that are to the power of 3, ne?
Yeah, those ones. The ones
Okay.
that are on calculus. Calculus, yeah, calculus. The questions are on question 7 and 8. Yeah,
You don't
on
know
the question paper.
you don't know the topics.
Um,
So let me see.
I do know the last one.
What is the last one? What is the topic
Wait,
for the
check for you.
I think it's cubic functions, the ones you're talking about.
Okay.
Um,
Um,
let's see.
um, um, yes, yes, okay.
Yes, you're talking about cubic functions, ne?
Yes, that one and that question on the practical problems. Yeah,
Okay. Practical
it's on
problems.
question 8. Yeah,
Question 8.
yes.
Oh, yeah. Yes. Okay.
Yeah.
It's fine.
And also, we didn't do integration that time.
Oh, we didn't do integration.
Yeah, so on paper one, we were left with
Hmm.
few questions. So those are the ones. On finance, I'm good. I can grasp finance fast. So yeah.
Okay. So finance is fine. It's just okay. So okay, question 1. We did logs. We did complex numbers. We did um, okay. I wanna come to our graphs, to the other
Okay.
ones, the remaining ones, ne?
Okay.
Okay. Um, what else? We did differentiation.
Yes.
We did that. Um, so we mostly left with graphs because the graphs are the
Yeah, we're only left with those ones only. Yeah. On paper one.
okay. Okay. So uh let's let's do a small revision on
Mm,
graphs. Right?
okay.
Let's do a small revisions on graphs. So we talked about linear.
Yes,
Oh,
and
separate linear.
quadratic.
Uh-huh. And quadratic.
Yes.
Quadratic. So what's happening with these ones? Um, with these ones. So for linear, we know the general formula is y equal
Y
to
equal to mx
mx
plus
plus
c.
c, with
Yes.
m being the
Gradient
gradient, right?
is
And then c being,
the y-intercept.
okay, y-intercept. And then
Yes.
for quadratic formula, we said then the formula, general formula is
Um, ax squared plus bx plus c.
plus c, right? And then
Yes.
a, we said a tells
It's
us
the shape
the shape, c is the
y-intercept.
y-intercept, right?
Yes. Yeah.
hmm And then, and then, so now I want us to come to the next one, right?
Okay. Yes.
I want us to come to the next one. So, should we start with exponentials?
Um. Yes, we can.
Okay, so let's come to exponential graphs.
Okay.
Uh, so exponential graphs, what do we know about exponential graphs?
Know that they
hmm So,
that
yes, I
you
saw.
have a
hmm So I just wanna show the shapes there first. So a
is
straight line, when we're talking about linear, they go like this, they are
straight.
straight. When we
Yes.
talk about these
It-
ones, quadratic
It's it's either smiles or it either frowns.
or frown, just like
Mm.
that, right?
Yes.
Um, okay, and then when we talk about exponential
Yeah.
graphs,
They sort
they
of like curve,
they curve.
but they don't touch the x and the y. They do, but they don't touch the.
They don't
If
touch
we
the.
have the asymptote, they do not touch the asymptote. Yeah.
Okay, yes. So here's what we have here now, right? So so what we have now is we have y equal to a x.
X.
Let's write this, right? Something similar to this, right? So
Mm-hmm.
the important thing here is that x is on the exponent, right?
Okay. Yes.
X is
On
on,
the exponent.
right? It's gonna be
Yes.
something, an example of it would be y equal to 2 to the power of x. This
X.
is an,
Yes.
see how x is at the top there,
Yes.
right?
Yeah.
Yeah, that's it. Right? So that's what makes it for us.
Okay.
So there's something that we need to know about exponential graphs, right? What is
Okay.
it that we need to know? Mhm.
Um, we know that
Mhm.
mm, we know that we have the we need to know the shape.
We need to know the shape, right?
Yes.
How do we know the
Yes.
shape?
Mm, by
Mhm.
by A
By
by A by
by A.
telling if it's positive or negative.
hmm And then what does that tell us?
On the example that you have given, it tells us that it's positive.
It tells us that A is,
Positive.
so so I wanted you to tell me something like, so so A, for A is for when A is positive,
Mm-hmm.
mhm, what is the shape? hmm
It's a curve, sort of
So
like
so
it curves like an L,
so let's say this. So this is
but
our
on the first
Y
quadrant.
and X, right? So it goes something like, so it comes on top basically. when A, so when A is positive, it comes where?
on top.
On top, right?
Yes.
So the so here's what I want to show. Okay, so man, not doing so well. So it will go like this, right?
Yes.
Or it will go like
That
this, right? It's
way.
not really on top, but it kind of is on, it goes like that, right?
Yeah.
So when A is positive, it kind of goes like this.
That
I think I need to refine this a bit more and tell you what.
way.
So let's not say just say positive. Let's say mm, okay. When A is greater than 1, right?
Mhm.
When
Yes.
A is greater than 1, the graph goes it goes up,
Okay.
right?
Yes.
When A is greater than 1, the graph is going up. It's not a straight line, it curves, right?
Yes. It curves
Right? When A is less than 1,
less than
right? When
yes.
A is less than 1, what happens?
The graph goes down.
The
It
graph
curves down.
goes like this, right?
Yes. Yeah.
It's decreasing here.
Mm-hmm.
Here it's what?
It it increases.
It's increasing, right? That's the that's the that's the first difference that we need to know, right?
Okay.
Mhm. That's the first thing that
Mm-hmm.
we need to note down. So if we were to plot, for example, let's try plotting y equal to 2x.
Okay.
Um, so y is equal to 2x, 2 to the power of x, sorry. So if we were to write the values, let's start it from -2 up until, um, so this, we're gonna put the x values there. Here we're gonna put the y values, right? Let's say here we have -2, -1, 0, 1, 2. Let's focus on that only,
Okay.
right?
Yes.
Let's focus on these values only, and then so if we were to plug in the values, so where x plotting -2, yeah, what do you get?
Positive 1/4
Oh, you get 1 over 4, which is 0.25.
is
Okay.
mm,
And then here, -1,
uh, 0.5
0.5.
is
At 0,
it's 1
at 1, it's 2.
and 2
At the here, it's going to be
4
4, right? So
is yeah.
what you see is that the values are increasing for y here.
Okay.
Right? It goes from 0.25 to 0.5
Mm-hmm.
to 1 to 2 to 4. It was going to go to 8, then 16, then 32, like that,
Okay.
right? So
Yes.
this is what do you this is how it ends up going to look like. It ends up going to look like this. This is y, this is x, like this. So it's gonna look something like this,
Right.
right?
Yes.
And the intercept here, the x, this point
Mhm.
here, right? What is this
Yes.
point?
That
That's
one
the
is
y-intercept, ne?
yes.
So what is the y-intercept in this case? To find the y-intercept, you put x equal to 0.
So
And when x is equal to 0 here, what is it? Your y is 1,
one.
isn't it? We
Yes.
were there. So this point here, it's what? It's 1,
It's one.
right?
Yes.
Right? It's 1. So if we were to put in, this is 1, right?
Yeah.
So and then and then we if they wanted the asymptote, what is the asymptote?
Mm, I think that will be
So this side from 1 going up, the graph is going up. It's gonna touch all y values, ne?
uh, yes.
It's going up. It's gonna match all y values. But when going down, there's a place where it doesn't touch. Where is this place? So
0.25 and 0.5.
no, it touches 0.5 because it's at 0.5 here.
Oh,
It's at 0.5 here. It's at
yeah.
0.25 here as well. So it touches those values.
Yes, the one that won't touch it.
So
2 and 4.
there's 2 here, there's 4. It touches.
Yes.
So the graph. So what I mean is that where will it curve and not reach? Because you know this one is gonna, it's gonna go like this.
Yes.
It's never gonna touch 0,
No.
right?
Yes.
Here, it's never gonna touch this.
Yeah.
It's gonna remain
And now,
going down like this, but it won't touch
yeah.
0. So 0 is our
Mm,
y
listen.
is our asymptote or y asymptote, right?
Yeah.
So at the asymptote is a place where the graph does not touch or does not reach.
Okay.
So if you say 0.25, 0.5, that's where the graph is.
Just.
It is
Mm,
there, so that can be an asymptote, right?
okay.
So
Yeah.
the y value that the graph doesn't touch, what is it? It's
It's
0.
0.
How do we know that it's 0? Let me there's a different way in which they write it. They write it for you guys. Let me see. Let me see. Okay, they write it in this form as well. They can write it in this form as well. This is another form they can write it, né?
Yes.
But the thing is, just know where they are putting their values at, right? So
Yes.
so I wrote it like this. Sorry, there was
It
a
won't be X
bx here plus c
plus C.
plus d here plus d, sorry,
Yes.
right? This
Mm,
last number here
is the asymptote.
is the asymptote.
Yeah.
It's the asymptote for both of them. It's the asymptote.
Yes.
Um, right?
Yeah.
So in that case, where I wrote y equal to 2 to the power of x, there's a plus 0 here that we
Mm,
didn't write. 0 is our asymptote.
asymptote.
Y is equal to 0 is our asymptote.
Asymptote.
Right? So if you were
Mhm.
to given, if someone was to say, oh, you have an equation, let's say example 2, you have an equation like this. It's 3 2x plus 4, for example. Right?
Yeah.
Then they ask for the asymptote.
It's 4.
It's not just 4. You
It's
write
Y equal to 4.
y equal to 4. That's the asymptote, right?
Yeah.
That's it. So, we saw what the asymptote is, and we
Mm-hmm.
saw. So here I'm giving you an a value that is greater than one, isn't it?
Yes.
So I've given values for where a is greater than one, right?
Yeah. Yes.
Where a is greater than one. So you plotted y equal to 2x, 2 to the power of x, and
Yes.
I give you y equal to 3 to the power of 2x. So a
Yes.
is for both cases I gave us an a which is greater than 1, isn't it?
Okay. Yes.
How about when the a is between 0 and 1? A is between what?
0 and 1.
0 and 1. Um, how about when a is between 0 and 1? An example of it is, let me write it with this one. If I gave y equal to 1 over 2 to the power of x, uh, and I said plot it. If you are confused for some things, it's okay to just do a small, you don't need to do massive things. You just
Mm-hmm.
need to just make sure that you know what's happening. So x is y, right?
Yes.
Just simple stuff. You don't need to do a lot.
Okay.
So x is negative 2, negative 1, 0, 1, 2, right?
Mm-hmm.
So how about when x is negative 1, is negative 2? Just plug it into your calculator.
Okay.
You're gonna get
It will
4, right?
be 4.
4. Here it's gonna be
Yes.
2, here it's gonna be 1, sorry, it's gonna be 1, here it's gonna be 1 over
Mm,
2.
2. Yes.
So 1 over 2 is 0.5, right? Let me write it like that. 0.5,
It will be
0.25,
0.25.
right? Do you see how
Yes.
this side is decreasing now, right?
Yeah.
It's what?
It's
Decreasing,
decreasing.
right? So,
Yes.
so this is the one where where we have a graph where we draw it like this. Mhm. So we draw it something, it goes something like this. Do you see?
Yes.
And then this is still one,
Mm,
right?
yes.
So if you have something like this, just know that the value for a is between 0 and 1,
Yes.
right? When
Mm-hmm.
it's decreasing like this, the value for a is between 0
Between 0 and 1.
and 1, right?
Okay.
When it's decreasing like that. I'm gonna show you the one that is negative, right? Where
Okay.
a
Yes.
is negative.
Okay.
A is negative. So what happens? What's happening there when a is negative? Mm. So, uh, so basically, uh, there are two things. There are two things. So let's give this way. So right, there's this,
Hmm.
and there is this.
Okay.
These two things are different.
Yes.
Okay? This one
Mm-hmm.
here, when we plug in y values, for example, for this one,
Yeah.
we plug y values like this. We plug x values, sorry, like if we were to go starting from negative 2, we'd go like this. Or let me put 1. Let me
Okay.
not start at negative 2. Let me put 1.
Okay.
Right?
Yeah.
Do you see now?
Yes, I can.
This one on the right, when we plug in values, we Sorry, what am I doing? What am I doing there? So for this one, I wrote it incorrectly. Um, I wanted to, yes, that no, it's fine. It's fine. I think it's gonna work out well. So, and then, yes, I see. I'm like, no, man, something is wrong with what I wrote. So here,
Okay.
where was I supposed to put one? On X, isn't it?
And X, yes.
So here we do something like this, and then here it's one, right?
Yes.
Let's put X is equal to let's say 2 first, just to get a proper
Okay.
conclusion, right? So so here the answer would
And
be, what is the answer here?
-4.
-4, right?
Yes.
And then here it's gonna go -2 to the power of 2. What is the answer?
+4.
+4. So you need to note down what is happening, right? So is
Yes.
it, are they giving you something like that, or are they giving you something like that? Right? So
Mm-hmm.
these options are different. This is different from this.
That one.
Right? So do you see now?
Yes.
Yeah. So so if they give you something like on the left, don't assume it's the same as this one. No, it's not the same.
Yeah. It's
Right?
not this
It's not the same.
same.
Right? So that's the important stuff. So here I
Okay.
want you to know, to note down that if the negative is on inside, yeah, uh, if the negative here is inside, it is the same as this one. It's kind of similar to this one, right?
Yes.
But it's not a function. Let's not, it doesn't
No.
become a function. Let's start with the one for negative, with a negative value. Let's start with
Okay.
this one. It goes like this. Y is equal to, let's say, -2 to the power of x. If we were to plot,
Mm-hmm.
if we were to sort of like start our thingy, we were to write it like this. Alright, let's just say this is x, this is y. -2, -1, 0, 1, 2, right?
Yes.
So here, what is happening? So you plug in -2 there. What do you get?
That's 0.25.
0.25, right? And then you plug in
Yes.
-1,
That would be -0.5.
-0.5. And then you plug in
Yes.
0, you get 1.
So it's 1.
You plug in 1,
It will be -2.
you plug in 2,
+4.
that will be +4. You see how this is, there's no pattern,
Yeah.
right?
Yes.
There is no pattern. It's here from there to there, it's decreasing.
It decreases.
Right? But from there to there, it's what?
It increases.
It increased. Right? From there
Mm.
to there,
It
it
decreases.
decreased. From there to there,
It increases.
you see there's no pattern.
Yes.
This one, it's not a function,
Yeah.
right?
Yes.
Oh, can you see?
Yes, I can.
It's haphazard, right?
Mhm.
So not,
Function.
so what they would give you is this one, the proper one. They would say y is equal to -2 to the power of x. Sorry, -2 to the power of x, something like this, right?
Okay. Yeah.
So, um, mm, so negative 2, negative 1, 0, 1, 2, like that, right?
Mhm.
So what would we get if we're putting
Okay.
negative 0, 0.25,
Mm,
right?
yes.
Negative 0, 0.5,
Right.
negative 0, no, negative
Negative
1.
1.
Sorry, negative 1 here.
Mhm.
This is negative 1,
Negative 2.
negative 2. This is negative
Negative
4,
4.
right?
Yes.
Do you see
Yeah.
how there's a pattern here? It's
Yes.
decreasing always,
Yeah.
right? It's what?
Mhm.
It's
It
decreasing,
decreases.
right? It's decreasing. Right? And the way in which it's decreasing, it's all negative. Can you see?
Yes.
It's
Yeah.
all negative. So the graph for this one, you draw your x-axis here, your
Mhm.
y-axis like this, and then this is like this. And then from here, this is how it moves. This is your y equal to negative 2x. Can you see?
Yes.
Right? This time it's on the lower side. It's on
Yeah.
the, it's
Lower
not,
side.
right?
Not one.
It's
No.
not like this one. It's not decreasing like this one.
Yes.
Can you see how this one is decreasing?
Yeah, I
Th
can.
this one is decreasing something like so, isn't it?
Yes.
Right? But this one here, where it's negative, where A is negative, like that one, you put, you're gonna have, it's decreasing like this.
Looks down.
It's looking down.
Yeah.
It's not looking ahead. Right?
Mm-hmm.
So that's the case for it. Right? And then let's do a negative, and that is between 0 and negative. So let's say the A value is between negative, let's say it's between negative 1 and 0. Right? So an
Yeah.
example would be something like this. Let's say y is equal to negative, right, 1 over 2,
Okay.
right?
Mm-hmm.
The only difference is that, okay, if we were to plot it, if we were to kind of like do simple, your x, this is your y, negative 2, negative 1, 0, 1, 2, like that. Right? What
Okay.
is the y value here?
Mm, it will be negative 4.
Negative 4,
Is negative 2,
negative 2,
negative 1,
negative 1,
negative 0.5,
0, comma 5.
negative 0.5.
Yes.
Mhm. Yeah.
So this is, let me just write it properly. Um, like that,
Yes.
right? And then,
Negative.
yes, it's negative,
Negative.
right? So
Yes.
this one is in this way. If you're to draw your x-axis, your y-axis, right?
Mm-hmm.
So you know that one was decreasing like this one, but this one is
Yes.
increasing, isn't it? It's this one is increasing,
It increases. Yeah.
right? So
Yes.
when it's increasing like this way, it's going something like so.
Yeah.
Can you see?
Yes.
And then this side here, this one is -1. That's where x is 0,
Yes.
isn't it?
Yeah.
So best you practice how to draw these graphs,
Okay.
huh?
Mhm.
Mhm. Because as soon as you're able to draw, you can solve. You can solve anything they
Okay.
ask because you know how the graph is supposed to look like and
Yes.
how different things affect the graph,
Yes.
right?
Yes.
So now, um, so now we investigated how A affects our graph. Eh?
Yes.
So just looking at what I've been saying, let's just say it's an exercise, right?
Okay.
It's
Yeah.
an exercise one. Okay? Let's say give me the shape of these equations. Let's say one y is equal to, let's say 4x and sorry 4 to the power of x, right? And
Yeah.
then give me the shape of y equal to -4 to the power of x, right? Uh, then let me use a different number. Let's
Mm.
say -3 to the power of x, and then um, something like this. Put it here, and then 3y equal to say negative 7 to the power of, sorry, not like that, to the power of x, like this.
Okay.
Negative y is equal to -7 to the power of x.
Okay. So our A, is it greater or is it what?
So we have a. So that
Of
greater thing,
we are using the one for example 3.
no, a is in each of the graph. Sorry. So here, this one is a.
Yeah, that's A.
That's a as well. That's
Yeah.
a. You determine whether a is greater than 1 or less than 1,
Okay.
isn't it? Because here,
Yeah.
for the first one, I'll say a is 4, right? And 4
Mm-hmm.
is greater than 1, isn't it?
Yes.
What is the shape of when a is greater than 1?
Okay.
When let me give you this. Since a is greater than 1, the shape goes like this,
Yeah.
isn't it? That's the shape.
Yes.
That's what I want you to give me,
Okay.
right? So for the second one, what is a?
A, um,
A is
negative
-3,
3,
and that means it's less than 1, isn't
less
it?
than, yes.
Right? If a is less than 1, how does it go?
It decreases.
It decreases. It's like this now. Hmm? It's like so.
That.
Let me just do this. Right? That
Okay.
is the shape,
The shape.
right?
Yes.
Mhm. So for this one, for number 3, let me do this. Simplify this. So just we just mhm. Right? And then for number 3, it's the same thing.
Yeah.
Right? It's still gonna look like this, the shape, right?
Hmm?
So this is something like this is your y, this is your x, like that,
Mm.
isn't it? So if I give you 4, say this is exercise 4, y is equal to -1/3 like this, and then this is to the power of x. What is
Yes.
what would be the shape?
Okay. The shape will be similar to number. Wait, to
So to give you a hint, let's look at this one. What is the shape of this one?
it increases.
It's increasing, but it's
Yeah,
on the lower side,
lower side.
right? Because of the negative. So it goes, it's like this. The shape, let me draw it better. This is the shape for it.
Shape.
See how it's increasing, but it's on the
Yes.
lower side, right?
Yeah,
That is the shape of our,
shape of graph.
mhm. And then that's the exponential, right? So
Yes.
there's a summary. Basically, this is a summary.
Okay.
This would be your summary. You look at A. If A is positive, your graph is increasing like that, right?
Mm-hmm. Yes.
If A is negative, your graph is going down
Increasing.
like that,
Meter.
right?
Yeah.
So the only shape that's missing is this one. So 5y, it's positive, but it's like this.
Mm,
So it's on the upper side, but it's what?
yeah.
But it's decreasing,
Yes.
right? Isn't it? This is the
Yes.
shape for this one. Okay. Then let's, what do we need to do? We need to, so the this next thing I want us to investigate is the,
Okay.
let's start with with the asymptote, right?
Okay.
For our occasion, if we simplify it, let's write it like this, right?
Yes.
You know that this one is our asymptote, right?
Yes.
We can increase or decrease, we can higher it and lower the asymptote as you wish, right?
Mm-hmm.
So I'm gonna plot two graphs for you. Here, there's this one, y is equal to 2 to the power of x. We've been plotting this. It's like this. This is x. This is y. The graph was like this.
That
This one
was
is
increasing.
1. It is increasing, right?
Yeah.
And then we have, let's plot this, y equal to 2x um, minus 1, right?
Mm-hmm.
So if we were to plot it, it would no longer pass through. So if we were to plot it, ne?
Yes.
Here we know the asymptote is what?
It's -1.
No, for this one,
Oh, it was 0.
asymptote is 0.
While, yeah,
0
equal to
is,
0.
yeah, let me write it properly. Y is equal to 0, like this, right?
Mm,
And then for
yes.
this one, what do we know about the asymptote for this one? We know the asymptote is supposed to be
Um,
-1, isn't it?
-1.
It's no
Yes.
longer 0. So
No.
we can draw our asymptotic line, the line for the asymptote here,
Mhm.
and write it as -1,
Negative 1.
right?
Yeah.
So if we were to draw this graph this time, we would draw it, it would pass through there. Right? Can you see now? It's perfectly joined here. Right?
Mhm. Yes.
So what is happening here? Let's see. If we were to draw that thing again, that table of ours, okay. Yeah, let's draw only that, right?
Yeah.
We know for this one here it was 0,
2, 5.
0.25. This one was 0.5. This one was
Um,
1.
1,
This was 2.
2,
This was 4. If
4.
we plot 3, this one would be 8.
Yeah.
Okay? Something
Yes.
like this. So I can just copy, put it here. Mhm. So now I'm gonna do one for this one, for this graph.
Okay.
So for this graph, right, for this graph, right?
Mhm.
So let's plug in the values for x, right?
Okay. It will be negative 0.75.
Okay. Is it
Negative
negative?
0.
Is it
Yes.
0.75?
No, it's 0.
0.25.
No, 0.75.
You minus one, eh?
Yeah.
Sure.
Yes.
Okay. Let's continue. We'll see if there's a problem in the. So
Mm,
for -1,
Negative 0.5.
-0.5. This one,
For 0, it's 0.
it's 0, and then for this one,
It's 1.
it's 1. For this one,
3.
3. For this one,
Mm, 7.
it's 7. Please redo this -1 just to make sure, just to be sure.
Okay. Uh, the one for negative 2, it's negative 0.75.
Okay, that's fine. Um,
For negative 1, it's negative 0.5.
okay, yes, that's fine. So let's look at here, right? The best way to compare, let's compare these ones. Let's
Okay.
compare these ones, right? With these ones, right? You don't need to compare the top ones. Let's just compare the bottom one. This one
Mm,
at 0, it's 1.
yeah.
At 0, it's 1. And this side at
Yes.
0 is what?
0.
It's 0. Okay, this one at 1 is 2.
2.
This one at 1 is
1.
this one at 2 is 4.
2.
And then this one at 2 is
3.
this one at 3 is 8. This one at
It's 7.
7. So all the values decreased by by 1.
Yes.
Do you see that?
Yeah.
So all the values decreased by 1.
Mm,
So what we basically did here, from there to there, this whole thing, it's a vertical shift. It shifts the graph 1 down or up.
mhm. Yeah.
This is what we call a vertical shift.
Shift.
It's shifting it up or down.
Shift. Mm, up.
In our case, it moved the entire graph down, isn't it?
Oh, yes, because of the negative.
Right? So if if we said the graph was shifted upwards by 2 points, by two units, right?
Yes.
The graph would be, so the new line would be y equal to 2x. We're shifting it by how much?
By 2 units.
By 2. Do you see what it means?
Yeah.
Because they will say, oh, our graph was shifted up by 2 units.
Mhm.
That means there at the end we have to add plus 2.
Okay.
Do you see? So
Yes.
so for this one, all the values would need to be go up by 1, by 2, sorry.
Yeah.
Right? You'd have to
Go up by two
go up by
units.
2. Right? So that's how you would have to do it there. Okay. Right? So for let me just consider the whole. So when we do this, this is what we call a vertical shift, either shifting it up or down.
Okay.
Right? And then for this one, um, so this is what we call vertical shift. Let's go to a horizontal shift.
Okay.
So horizontal shift, let's say 2 to the power of x, y is equal to 2 to the power of x, sorry. And then we have our y equal to 2 to the power of x plus 1, right?
Yeah.
If we are adding, or if we're adding or subtracting on the power on the exponent, we are shifting
Mhm.
the graph horizontally.
Horizontal. Yes.
Right? Can you see it?
Yes.
So we know, we already know this one, the 2 to the power of x1. Eh?
Mm.
The 2 to the power of x1 is this one.
Yes.
Here it's what? It's 1.
One.
This is 2 to the power of x. And then this one here, 2 to the power of,
X plus one.
right? Just like this, let's say this one would be 2 to the power of x plus 1, right? So
Yes.
here, so
It's two.
where there was, where this one was, it's gonna shift to the left like this. Shift from here, shift from
Mhm.
1 and go where? This side, right?
Okay. Yes.
And where this one here was 2, right? It's gonna
Mhm.
shift this side. Do you see it?
Yeah. Yes.
Right? So we didn't move it up, we moved it to the side.
That's-
Do you see?
Yeah.
We this time we moved it to the side. Right? And then we're gonna find out that this is gonna be a 2. Right?
Yes. Yeah.
So um, there's different ways. We can shift it to the left, to the right.
Okay.
So if we are shifting it like this, if it's x plus 1, we are shifting it to the left.
left,
If it's x minus 1, we are shifting it to the
right.
right. Can you see?
Yes.
Yes. Alright. Um, I just wanna go through one small example with you. That so okay, so they didn't bring an exponential, or they brought it.
Yeah.
Right? So they have, here's the question. Given the given functions for f and h are defined by f of x
Mm,
minus 1, f of x is equal to 3 to the power of x minus 1,
yes.
right? And h of x is equal to the square root of 25 minus x squared.
Mm-hmm.
Right? Write down the equation of the asymptote of f.
Okay. It will be y equal to -1.
Y equal to -1. That's correct. Right? And
Yes.
then the domain. Yeah. This one, what sort of function, what sort of question is this?
That one it's a semicircle.
It's a semicircle. Okay. So, and they, they said determine the x-intercept of f.
Yes.
Right? So let's kind of let's draw it. It's what? Um, so if we were to draw it, how would you draw it? This one.
Mm, we'll draw it like
So it's similar to we
to
drew to this
that
one,
one. Yes.
isn't it?
To the vertical one. Yes.
We are shifting it down,
Down. Yes.
so it's gonna pass through 0 here
Yeah.
for this one, right? Because the best way, if you get confused for these things, eh,
Mm-hmm.
start by drawing the simple one. Start by drawing this one alone.
Oh, okay.
Right? If you get confused, draw it alone first, because you know this one is gonna
Mm-hmm.
look like this, isn't it?
Yes.
But now you saw, now there's a minus one. Minus one
Okay.
means we are what? We're shifting it down.
Passing down
So this one, we're shifting it down by how much? By one.
by one.
So if we shift it down by one, that means this one is going to move from there to there,
Yes.
isn't it?
Yes.
And when it's like this, it's going to move here. It's going to go.
Down. Up.
Do you see? So, and our asymptote here for this one that they didn't ask for this one. The asymptote was y
No.
is equal to 0. But now
Yes.
we are looking at what? At this one.
Yes.
The asymptote for this one is y
Y
equal
equal
to
to
negative.
-1.
It doesn't touch -1. It just goes like this, right?
Yes.
So you see how I drew it, né?
Yes.
You can start with a simple one without the minus, and then when you see the sign, then shift it down,
Yeah.
right?
Mm-hmm.
So what is the x-intercept?
It x-intercept with
It's where it touches the x-axis, right?
x-axis. Yes.
Where does it touch the x-axis? It's here.
Yeah.
It
It's
touches
0.
it touches both the x-axis and y-axis. Yeah.
Yes.
So x-intercept is x is equal to 0,
Yeah.
isn't it?
Yes.
Yes. So Determine the y-intercept of f.
Y is equal to 0.
Y is equal to 0 as well.
Yes.
Right? So here when they say the sketch,
Mm-hmm.
right? So we've already sketched a f,
Yes.
isn't it? What is left is sketching h. Right?
H.
So out of that 3 marks, out of that 5 marks, sorry, for sketching, we already have 2
Yes.
for sketching f, right?
Yeah.
We already have 2 for sketching f. We can then sketch other things if we want. Yeah?
Okay. Yes.
So let's do this. So, and then the next question, which is the one I know that most of us kind of get lost in. Okay, here this says using your graph, blah blah blah, right?
Mm-hmm.
So what does this equation mean? F of x times h of x is greater or
Plus
is less or equal
and
to
0.
0. So,
Yeah. Hello.
hmm,
Hello.
yes, you can hear me, no?
Yes.
Yeah. So what do they mean there? So
Mm-hmm.
so yeah, this one is very simple. When they say so h of x multiplied by g of x, what do they mean?
They mean mm, they mean that the values will they mean that both the equations multiply one another.
So that's what they mean, but they're not talking about the equation per se, right? They're talking about the y values. So
The y
y
values
for h and the y value for g.
G
When they multiply each other, they have to be negative.
or
Less than 0 is what?
negative.
It's negative. 0 is 0, right?
Yeah.
So where do these things, when they multiply, they they give us a 0 or a negative number?
Okay.
They have to be 0 or
Negative number.
negative. Where is it? Right? So
Mm,
what do we know? I'm just going to give you the general approach to these questions.
okay.
Mhm. So um, okay, let's continue. Um, so the y for h, right? So like we know what the y value is. The y value
Yes.
you can calculate
Negative one.
-1. So y value, the -1 is the asymptote. It's not for everything, eh?
Oh, yeah.
Right? It's the asymptote. Here, let's say here you have a value for that's positive. Let's say you have a 2, and then you
Okay.
multiply this one by a 2 or 3, right? Let me
Yeah.
write it properly. So it's multiplied by a 3. What is the answer? Is it a positive or negative?
The positive
It's a
one.
positive, right? Positive, sorry, right? And then,
Yes.
so when do we get a negative number? We get a negative number when one is positive and
And
the
the
other
other
is
is
negative.
negative.
That's what they want. This one could be
Oh,
negative
okay.
and then this one could be positive. If they're both positive, they're going to give us a positive number,
Yeah.
right? So we are looking for negative numbers, isn't it?
Yes.
So that's it. That's what we have to tell them.
Okay. So
Mm.
mm, so
Yes.
those numbers were already given, correct?
Which numbers?
For f of x, for h of x and g of x.
Yeah.
Okay.
Mm. Yeah.
Um, but I just wanted to clear the confusion. So it will be the numbers
So okay,
on the graph
on the graph
that were given.
that we are given. Yes.
Okay, so for example, if they give us negative 2 of x, so that will be the one for h.
Yes.
Okay, okay.
Yes.
I was just confused about it, that's why. I thought you used the ones, the numbers that you plotted already.
No.
So that's why, yeah.
Um,
But also, I have received the timetable, so the dates are the same as those ones.
so you're starting on the 19th,
The 16th,
16th. Okay. Yes.
yeah,
Or 16th and then 19th and then
23rd, and
20th
then
and
on the
20th.
26th.
Yes. Okay.
Mm,
Right. So this is what they mean by those questions. Ne?
yeah,
So let me, yeah, let me leave it there here for this one.
okay.
Mm, um, so let's. mm, mm, okay. So here, let's come to this one.
Okay.
Mhm. So the graph below represents a function g defined by g of x, a, right?
Mm,
They gave us the information.
yes.
And then they're saying, so determine the equation in the form,
Oh, G.
right? So they gave us the thingy. Now they want the equation. How do you go about
Yes.
to find the equation there?
Mm, you use the you use the points on the graph.
You can use the points on the graph, right?
Yes, yes.
Right. So how do we do it? Um, let's do this. Let's put it this way. Yes. So how? Sorry, I was just answering something here. So
Okay.
how do you go about it?
Mm, okay. You're gonna put the points of um let me check. You're gonna use the points of k
Hmm.
on the given um and the given
So
equation.
so um, okay, what is it? This or this one?
Yes. Mm,
Okay.
yeah. And we're gonna use the points of k.
Hmm.
Hmm? No. Yeah.
You're gonna use
Mm,
what?
the points of k.
So if we use the points of k, let's do this. X is 3, b. What is x? X is
Three.
3, like that. Right? So we're gonna have
Mm,
4 equal to this 3 squared is 9,
nine.
so it's 9a plus 3b
3b.
plus c.
Yes.
Right? Can we find both a, b, c? Can we find all of them?
Mm,
We can't so far, right?
no. Yeah. So
So,
that's
so, so another way, you have your formula for
yes.
for turning point, isn't it?
Yeah. We
What does
can
it say?
use its x
Mm,
equal to minus b over 2a.
over 2a, right?
Yeah.
If you use this, what do you get? So x is what?
It's
For the
x
turning
is
point.
3.
No, this is for the turning point,
Well,
isn't
for
it?
the turning point,
This
x is r.
formula is used for the turning point. X
Yes.
is
R 1
it's 1, then minus b over 2a,
2a.
right? So if we were
Yes.
to solve for a and b, you would have to multiply by 2a here,
Yes.
multiply by 2a so that a moves there, and then it's gonna be
Yes.
2a is equal to minus b,
Minus b.
right? Then
Mm-hmm.
so and then what would you do? You would maybe divide by negative both sides, and then you get
Yeah.
negative 2a is equal to b, right?
Yes.
And then you can take this b and put it on top there,
Yeah.
right? So basically this is simultaneous, by the way, if you didn't notice. So turning point was 1 and 3, negative 3, right?
For the one that were given,
The turning points,
no, it was -4.
negative 4, sorry. Um, negative 4, okay,
Mm-hmm.
that's the 10. This is basically simultaneous. You need to solve it the way you do a simultaneous equation. So let's continue. If we take b, this b,
Yes.
and then let's say you put it back in here. Right? What do
Mm-hmm.
you get? You're gonna get 4 um, 9a plus 3b. Oh, sorry,
Mm-hmm.
not b. B is now negative 2a, isn't it?
Yes.
Plus c.
Yeah.
So this would simplify. This is 9a minus becomes
Six.
minus
Six
minus
a.
6a plus c.
Yes.
Can simplify this one. Can simplify becomes what?
3.
What becomes 3a, isn't it?
Yes. Yeah. 3a plus c.
So
mm,
this one,
mm,
this one is one of the equations that you have,
yes,
isn't it?
yeah.
Mhm. Um, then what else? Well, how do you move forward from here?
Then, oh, then from here you can use then from here we need to find C.
You need to put what?
Mm,
So
mm.
what do you need to put?
We need to put the values on K, the points that we have on K.
Yes, so we can put the points that we have on K.
Yes.
Let's put them
So
here.
we
We put the turning points, not the. Oh, we did. We put the values on
we
of K.
did.
So
Mm,
we can put both. We can put values on turning points.
okay.
Right? We can put the points on turning point. So y for the turning point, y is -4.
Mm,
For the other points, it's y, x is 1 plus
yes.
b plus c. This is 1 here as well.
Mm,
Becomes what? -4 a plus b plus c, like this.
yes.
Right? So
Mm-hmm.
um, if we were to put in this one for this equation for the turning point,
Yes.
put it here
Yeah.
as well, what would we get? So I just want to make it
Mm,
visible.
did you
So -4,
A
-2a, sorry, -a, would it work? Would it give us -a minus 2a, isn't it? Plus c,
is
right?
C.
So this is what we have right now. So this can also simplify. -4 is equal to -3a plus c,
Plus C.
right? Like that.
Mm,
So we have two equations now.
yes.
Can we see them?
Yeah.
Hmm.
Yes.
Hmm. So how do you how would you do this equation? So it's a
Mm,
simultaneous. You could do it the simultaneous way,
yeah.
or let's do this. Let me copy it and paste it here. Right. So this
Mm,
one, the top one would be the equation one. This would be
mm,
equation two.
equation 2.
Right? And then if we said equation one plus equation two,
Mm-hmm.
what would it be?
Or if you add both of them,
Mm,
2, 8, and negative 6 a c squared. Equate. So you
So
have to add both of those
so
things.
you're adding
Yeah.
this, then you're adding this. Simple.
Yeah, it's
So when you
what
add
I was
these on
saying.
a zero, this
Mm-hmm.
one 0 plus 2c, then you're gonna get
C
c
0.
c 0.
Yeah.
Right? isn't
Oh
it?
yeah. So yeah,
Right?
correct.
C is 0.
Now I was also double checking if I was doing it on my head. I was like, oh yeah,
Yeah.
correct.
Okay. So, and then knowing C, you can solve using any one of the equations.
Okay.
If we use equation 1, we can solve for A, right?
Okay.
So we know 4 equal to 3A. C is 0. So you can put 0 or
Mm-hmm.
just delete there, right?
Yes.
What is A? We need to divide
No,
by 3.
three,
Your A
not
would be 4 over
about three.
4 over 3. And then we have A. Now, using this equation here, we can solve for B.
Yes.
What is B? So
Mm,
B is equal to negative 2A, and then negative 2. What is A? A is
mm, 4
3, sorry,
over 2,
4 over 3.
which will be negative 8 over 3. Yeah.
Right? Just like that.
Okay.
Right? So if you write it,
Yes.
if you were to write this equation, it's what?
Mm,
So y is equal to,
okay. Negative 8 over 3.
but something is wrong. Let's just say this is it. But we made a mistake somewhere.
Okay.
Hmm, Sorry. Oh, the negative one is B, not A. Sorry.
Mm,
Yes. So I thought it was wrong because it was gonna give us a sad face, but the graph is positive, isn't it? It's a
yes.
smile. So that's why I thought something was wrong, but yeah, it's correct. Right?
Okay.
So B is 4 over 3, which is
3.
positive, right?
Yes.
X squared, right?
Mm,
Minus 8 over
3.
3x. That our C is
Yes.
0.
Yeah.
So this is how our equation would look like.
Okay.
Right. So for now, that's what we have. Um, I think let's let's come back at 4. We're gonna do 4 to 5, and then we're gonna do hyperbolas.
Okay.
Yeah.
All right.
All right.